All right, today we're going to look at the end behavior of polynomials. What we've done thus far has given us x-intercepts, y-intercepts, things that happen close to one of the two axes. Today we're going to look at what happens when you get very far away from the origin. Okay, so let's look at this first function, x squared plus 1. And we want to know what happens when we put in very, very large positive values for x. So to do that, we're going to go to our calculator, and we're going to pick some really large values for x. For example, let's start with maybe one that's not very large, 10. If I square 10 and then add 1, I get out 101. Now, I'm going to make this input start getting very, very large positive, right? So what happens if that 10 becomes a 100 and I square it and then add 1? It's another very, very large positive value. What happens when I square 1,000 and then add 1? Notice what's happening. I'm getting bigger and bigger and bigger positive values. Okay, so when I have very large positive values for my input, I'm going to get very large positive values for my output. Now let's see what happens when I put in very, very large negative values. So if I put in negative 10, and square it and add 1, I get the same thing as if it was positive 10. If I put in negative 100 and square it and add 1, or if I put in negative 1,000 and square it and then add 1. Look what's happening. I'm again getting bigger and bigger and bigger positive outputs. So I'm going to get large positive outputs. Okay, let's think about what this looks like graphically. So graphically, right, we're going to have some stuff in the middle near the origin. We're not sure what it looks like. But when I put in very large positive values for x, I'm going to get very large positive values for y out, right? Very large positive values for x. It's going to lead to large positive values for y. So my graph is going to go up this way. If I put in very large negative values for x, well, where are those? All the large negative values are to the left, and my graph still gets bigger and bigger and bigger in the positive direction. So this graph is going to look like it opens upward, and we're not surprised by that because it's a quadratic with a positive leading coefficient. Let's look at what happens with the graph of g of x. Okay, if I pick very large positive values for my input, right, we're looking at specifically what is going to happen with my graph as I get bigger and bigger and bigger x values. So I'm going to come back here, and I'm going to put in 10, and I'm going to cube it, and then add 1. I get a very big value for my y. If I put in positive 100, and I cube it, and add 1, I get an even bigger value. If I put in positive 1,000 and I cube it and then add 1, even bigger positive value. So look how this one grows even faster than the quadratic. But if I put in a large positive value, I'm going to get a large positive value out. So my graph is going to look like this on the right-hand side. What happens if I put in a large negative value? So let's go back to our calculators. I'm going to put in first negative 10, then cubic, and add 1. And I get a pretty big negative number. I'm going to put in negative 100. I'm going to cube it and add 1. An even bigger negative number. I'm going to put in negative 1,000. I'm going to cube it and add 1. Look how my numbers are getting bigger and bigger and bigger and bigger in the negative direction. So what will that look like graphically? As x goes negative, my y value is going to get bigger and bigger and bigger to the negative. So large negative values give me large negative values out. Okay? Now, let's go down to these two functions. Look at the only difference here is we have negative leading coefficients now. So as I put in large positive values for h of x, go to my calculator, it's negative 10 squared plus 1. Notice how I wrote that. I get a pretty big negative number out. Negative 100 squared plus 1. I get an even bigger negative number out. Negative 1,000 squared plus 1. Even bigger. So as my values for x get bigger and bigger and bigger in the positive direction, my outputs get bigger and bigger and bigger in the negative direction. So a large positive value for my input gives me a large negative value for my output. Again, we're going to look at what is happening for my graph. If I put in very large negative values, now I'm putting in negative 10, then I'm going to square it and add 1. Same thing. I put in negative 100 and I square it and add 1. Notice what's happening to my values. Whoop, there should be a negative in there. Let's just clear that. Negative 1,000 squared, add 1. Notice my numbers get bigger and bigger and bigger in the negative direction again. So I'm going to get large negatives out again. So as my x value moves very big in the positive direction, I'm going to get very big negatives out. And as I move very big in the negative direction, I get more negatives out. Again, not surprising, because I got a quadratic. It's got to both open the same direction. And this one has a negative in front, so it goes down. Last but not least, what's going to happen with this function, k of x? I got the negative outside, and I'm going to put in a positive 10, and now I'm going to cube it and add 1. Whoop. Negative out front, positive 10, cube it, and add 1. I get a pretty big negative sign out, negative number. What happens when I put in 100? And I'm going to cube it and then add 1. Even bigger negative, right? So as my x value moves very big in the positive direction, my y value gets large in the negative direction. Okay, again, this is all about what's happening around the ends of my graph. So this one, large positive input, is going to give me a bigger and bigger and bigger negative output. What happens when I put in a large negative input? Oh, I get a positive output. It looks like, oh, we'll go to 1,000. We'll skip 100. We're going to cube that and then add 1. Look how big. It's a very large positive output. So if I come over here, a very large negative input is giving me a large positive output. What's that graph going to look like? It's going to look like this. Okay, so look at our end behaviors. Okay, end behaviors. What's important to realize here is that we have kind of a pattern. Okay, and I will show you that pattern in the next video, and then we'll move on to these examples.